This course covers everything you'll need to know to be an expert in asynchronous programming in C#. This course starts out by introducing the differences between asynchronous programming and parallel programming and how we can do that with async await. We'll start out in this course by learning about the differences between parallel programming and asynchronous programming and how they work together with async await. Then once we're experts on how async await works, we'll actually dive into the compiler-generated code, because you may not know that every time we create an async task method in C#, the compiler generates a struct, and we'll look at all that generated code and how it works. Once we're experts on async await and how the compiler generates code when we use async await, then we'll actually create our own task. That's right, we're going to write our own code that mimics the class task that exists in the .NET runtime, but we're going to do it ourselves to really understand the internals and how the mechanisms work inside of task. And even cooler, we'll be able to use async await with our own custom task. Then, once we know how everything works under the hood, we'll talk about async await best practices. We'll talk about the best way to use async await in our code by leveraging things like value task and configure await false. And then finally, we'll dive even deeper into the .NET internals to introduce concepts like thread static, like iPrinciple, like execution context and synchronization context to really understand what's going on under the hood. Now, if you're excited as I am for asynchronous programming in C#, join me in the next video to talk about the prerequisites for this course. This course is designed for advanced C# users. If you're brand new to C#, that's fantastic, and I'm excited to see that you're interested in learning more about asynchronous programming. But I highly recommend first taking some beginner courses on async await on task to understand how to write that code and to have a general idea about how it works. Because this course assumes that you've written C# code before and that you've used async await before, but maybe never really dove into the internals under the hood. So if you're new to C#, pause this video and watch a couple introductory courses on async await, task, and parallel programming. Write a little bit of code yourself to get a feel for it, and then come back and join me as we dive deep into asynchronous programming in C#. Welcome to the first section, an introduction to asynchronous programming in C#. My name's Brandon Minnick, and I am so excited to dive into this topic with you, because if you've written any C# code, you've likely quickly come across the concept of asynchronous programming using tasks, using threads, using async await. In this section, we'll discuss all of that. We'll start by looking at code before async await was available to us to help us understand why async await is so powerful. We'll discuss the concept between asynchronous programming and parallel programming. And lastly, in this section, we'll dive a little deeper into the concept of a task and a thread and what all of that means in C#. But first, let's dive into the code. Now today, we'll just be working on a simple console app. This code is all available to you if you'd like to follow along, or if you'd like to just download the completed solution, you can get that in the course materials as well. Now, in this sample here, I've created a class called food. Now, this is an abstract class that requires a cook time. And the idea here is that we have a public async task method called cook that before we start cooking, we'll print the name of the item we're cooking. It'll run task.delay, which essentially delays this task from running for the specified cook time. And then when we're done, we print to the console that the cooking's been completed. I've also gone ahead and created a couple classes. I've created a turkey, mashed potatoes, gravy, stuffing, all our favorites for the Thanksgiving holiday here in the US. And for each of these, I've inherited from food and I've passed in a cook time. So let's first look at what asynchronous programming means before async await came along. So here in this console app, we're going to start out by just printing to console.writeLine and letting the user know that cooking has started. And then what we're going to do first is to create an instance of our turkey class. And then we can call turkey.cook. Now, let's run this code and see what happens. Okay, build succeeded. The code ran. It printed to the console cooking started. It printed to the console cooking turkey, but then it finished. We never printed to the console what we expected to see here inside of cook, where it says we start cooking the turkey, then we delay for the specified cook time. And when it's done, we're supposed to say cooking completed. But the problem we're running into here is we're not waiting for the cooking to finish before the program is ending. And in fact, we're even getting a warning here, letting us know that we should be using async await, although we're not going to use that in this example just yet. The warning says we should use async await because this call's not awaited, and the execution of the current method continues before the call has completed. And it obviously advises us to use the await operator, which we will. We'll get to that, I promise. But for this example, what's happening is we're hitting this line first, then we're creating our new turkey, so we're hitting this line second. Then we call the cook method. So our code jumps into this async task method. It prints to this prints to console.writeLine, cooking, in this case, turkey. And then we hit this await keyword where it says task.delay. And when we hit the await keyword, that actually tells C# to return to the calling method. So our code actually comes back up here, and our code continues running on this line while that turkey is being cooked in the background. Now, because this is also the last line of our code, this is where our console app ends. That's why we don't see that the cooking turkey has completed before the app ends, because we hit this line of code first, cooking started. We initialize our turkey object. Second, our code hits turkey.cook. We enter into this method. We print that we're cooking the turkey, just like we see in our console. And then as soon as we hit this await keyword, our code resumes running on this line here, which is just the end of our program. Now, before async await existed, what we would do here is use what's called callbacks. So we would say here, continue with, and inside of continue with, it allows us to pass in an action. So in this case, what do we want to do when the turkey is done cooking? Well, why not make some gravy? So now this line of code will continue once the turkey's done cooking. So why not say, create a new class called gravy, and now we can start cooking the gravy. First, let's fix this compiler error, and let's click run. Okay, so the build succeeded, and we see that we printed to the console, cooking started, cooking turkey, but then that's it. And that's weird because we added more code here. We added the continue with, but let's think about what happened with our code again. Well, we hit console.writeLine first. We initialized our turkey. We called turkey.cook, which called this async task method where we printed cooking turkey. And then as soon as we hit this await keyword, our code returns and continues running down here. So again, our program finished executing before the background task of cooking the turkey finished. So let's do a little cheat here in console apps, because what we can do is we can say console.readLine. And what this tells the program to do is to say, wait for an input from the user. You're going to read a line of input from the user. And until the user does that, don't kill the process. Don't kill this console app. Let it continue running. So what this should allow us to do is see that the turkey completes cooking. And we should see also that the gravy completes cooking as well. So let's run this now and see what happens. Okay, build completed. We see we're cooking the turkey. We see that the code hasn't ended yet. Oh, there we go. The turkey completed. We're cooking the gravy completed, and the program's still live because it's waiting for me to input text. So I can just hit enter, and now the process finishes. So now what's happening is, just like last time, we're starting out by calling console.writeLine cooking started. We initialize our turkey. We call turkey.cook. And again, that enters into the cook method where we hit the await keyword. The await keyword tells C# to return to the calling thread and to continue running here. Now console.readline is actually preventing our application from finishing until I've inputted a line. Now, I didn't enter a line until the gravy completed. What was happening was that on a background thread, the turkey was cooking. And when that background thread completed, the thread continued with these lines of code here, where we initialized a new gravy instance and we called gravy.cook. Now, again, because I did not terminate this console app by entering any text into the terminal, it also kept running until we saw that the gravy completed as well. Now, this is an example of async await. Before we had the async keyword and the await keyword, we were forced to write code that looked like this, that this works, but we're running things on background threads. We want to wait until the cooking is finished until we continue to the next line of code. But in reality, our code was jumping all over the place. Let's jump back into the slides and see how this looks. Here's a screenshot of the code we were just working on with a couple more console write lines to make it very explicit about what's going on. And we can see here in the console output that when I call .NET run, we see cooking started, cooking turkey, turkey completed, cooking the gravy, gravy completed, and that everything's ready to eat. And just like we saw in the example, the first step was that we printed to the console, specifically console write line, to say cooking started. The second step was printing that we're cooking the turkey. Then we initialize the turkey. Step 4 calls turkey.cook. And unintuitively, step 5 jumps all the way down here to the bottom, this console.readline. And that's because we're cooking the turkey on a background thread. Meanwhile, the main thread, the thread that kicked off the program, is now waiting for me, the user, to input something into the terminal. And then once I do, it'll terminate the task. But again, remember, we did that on purpose so we could let the background tasks complete executing before we terminated the process. So step 4, turkey.cook, and then step 5, all the way down here, console.readline. And then step 6, we jump back up into the code for console.writeline, turkey completed. Step 7, we printed to the screen that now we're making gravy. We initialize our gravy object. We call gravy.cook. And then again, I've added another continue with here for when the gravy's done cooking, we print gravy completed, and then we print ready to eat. This is what was known back in the day as callback hell, because continue with is a callback. It's where we can insert code inside of this method, inside of continue with, that'll run once this cook task has completed. But as developers, this code starts to get very difficult to read, very difficult to maintain, because normally we read top to bottom, left to right. So intuitively, when we read through this code, we would expect it to execute in order of line by line. So I would expect that the cooking would start, we print that we're cooking the turkey, we initialize the turkey, we call turkey.cook, that step 5 would be here, turkey completed. But as we know, when we hit the await keyword, it kicks off that background task and it tells the calling thread to return, which is how we jump all the way down to console.writeline. And this callback hell was very, very difficult back in the day. And fortunately for us, the amazing smart engineers at Microsoft created a solution called async await. In the next section, we'll jump back into this code to re-implement this using the async await keywords. We'll see you then.